All right, here we go. No explanations, no nothing. I'm going to go ahead and try to solve this problem. Okay. Magic scores are scores of numbers. So, given a 4x4, one squares, determine if it's a magic square. So, how do we know if it's a magic square? Okay. So, each column and then each row. Okay, interesting. Okay, so let me first of all get the square, which is just going to be an input. I'm assuming it's going to be a string because it has all these spaces which are not allowed in integers. And let's get each of the rows. So for the rows, I'm going to say row. First of all, this is going to be so there's going to be 4 of these. So we can just assume that each one of those is a row. So row 2 input, row 3 input, and then row 4 because there's 4 rows in all of the examples I was given. See, it's all 4. So okay, now what I'm going to do is I'm going to make these all into lists. So I can just do that over here. I can just split, and we're good to go. So those are the rows. Now for the columns, it's just going to be row 1s for each of the elements. So let's go ahead and get the columns. So column 1, which is going to be row. So I'm going to put these into a list. So it's going to be row, the index 0, not 1, because remember index starts at 0. And then this is going to be row 1. So then row 2 is going to be 0. Row 3 is going to be 0. Row 4 is also going to be 0. And we're going to copy this for all of them. So it's going to be row 1, which is going to be 1. Row 2, which is going to be 1. Row 3, which is going to have the 1 index. And then row 4, which is going to have the 1 index. So that's getting all of these values. So this one, this one, this one, and this one. And then column 3 is going to be row 2. Sorry, so row 1, 2, row 2, 2, row 3, 3, row 4, 3, and then column 4, which is going to be row 3. So row 1, I keep messing up. Row 1, 3, row 2, and then 3 index, row 3, and then 3 index, and then row 4, and then 4 index. Okay, there we go. So now we have our rows and we have our columns, and so now we can just we can check if everything adds up. So all we want to do is for each one of these, we want to, is it add or multiply? Yeah, add. So we want to add each one of these up and then have that addition. Okay. So all I'm going to say here is for each row for the So I'm just gonna run multiple for loops, I guess. I'll do that. So for row in row 1, what we will do is we will add it to the count for row 1. So these are the sums of the rows and columns. Oops. So I'll start off with sum underscore row 1. So here, so for element, I'll say actually for element in row 1, sum underscore row 1 will be added to, the element would be added to that. Then for element in row 2, do the same thing, but for sum row 2, equal element, and then for element in row 3, do the same thing. And all of these will be being initialized over here, right? So we can actually increment. And then for element in row 4, sum of row 4 should be added to that element, and then we will get that from here. So row 4, right? So all of that will be grouped together, and then now for element in column 1, so this is a lot very repetitive. The sum of column 1 will be added to the element, and we're just going to keep doing this. There's probably a much better way, I'm going to look at it to do this, but for now this gets us the answer, so we're good. But yeah, we definitely have to have that mindset of looking at the best possible answer, right? And then so for element in column 4, sum of column 4 is going to be the element, and then now I'm just going to go ahead and add these. And then this is sums of the columns counter, iterating over the different rows and columns. Sum. Okay. Let's go ahead and try this out. Where did I say 4? Oh, I said 4 here by accident. That's my bad. Okay, let's just go ahead and add this here. So paste that. Wow. Right, these should be, so I'm just gonna do this for each of these elements. They should be int and then elements. And then this shouldn't be an integer. Okay. Let's try this out now. Okay, perfect. So it's computing, and now we have to see if we get magic or not. So for that, we need all of these sums to equal. So I'm just gonna say if sum underscore row underscore 1 equals sum underscore row underscore 2 equals sum row 3 equals sum row 4, which equals sum column 1, sum column 2, sum column 3, and then sum column 4. Print magic, right? Because all of these different variables are equal. Otherwise, we're gonna say not magic, right? So let's try this out. All right, there we go. So there seems to be an issue here. Let me try this. So magic. Okay. So I'm basically going over each one of these and then adding it. So like 5 plus, let's try like 16 plus 3 plus 2 plus 13. 16 plus 3 plus 2 plus 13. 34, right? Yeah, it adds up to 34. So that's exactly what I'm doing here, right? So I'm not sure where the issue is. Maybe let me see. Let's say sum column 1. I just want to see what it's giving me. So let me go ahead and get this here. Okay, I'm getting 34. Let's try another one. Sum column 4. I'm getting 34 again, so I'm not sure where the issue truly resides. Ah, there it is. This has to be 2, and this has to be 2. I don't know why I wrote 3. Maybe from confusion, I guess. So there we go. Now, this should give me magic. It's going to give me magic. Let's go. Okay. So it was just a matter of getting these incorrect there. Okay. Perfect. And now let me try the other one out as well. So here it is. Let's go back here. This should still give me not magic. Perfect. So if we go ahead and submit this solution here. Perfect. Do we get full marks? So there we go. That is magic squares fully done. Just a little bit of an issue with the indexing here, but otherwise everything was good. I'm gonna comment my code now. Okay. All right. And there we go. Let me take this. Let me just put it in here again, just to make sure that the comments didn't mess anything up. And yeah, there we go. So let me take this and let's put it into 2016. 2016. So this is going to be magic squares.py. And then there it is. And then clear git add dot git commit am git push git pull, I'll actually say git push origin head, and there we go. So now it's on my GitHub. You can check it out too. Just go to this repository. I should have probably said this in my previous videos too, but you just go here to github.com, Hemet99123, CCC prep. I even have some extra in mock and sweat, some extra different questions that you could try out too and their solutions. But now if you go here, you go into the 2016 folder, you will see magic squares, and then you'll see my solution for magic squares in there. And this is the correct solution. We can go ahead and look at some of the good solutions as well. Let's filter to Python. And let's see here like this. Yeah, we could have done this as well. We kind of streamlined this process by doing it manually because there is predictable, so we could just do it this way. But we could have put these into for loops as well. I didn't see the point in doing that, and that would add more time complexity. This is just going to be simply O of 1 or constant time, so it's pretty negligible in that sense, right? So that's why I felt like this was good. But yeah, I mean, there's multiple ways of solving this problem, right? But actually knowing the logic, commenting on your code on the test, you should be good.